Hi, I'm Mr. Manley, and this is a video on quadratic functions. Quadratic function, I'm sure you probably associate with a parabola, and the things that we're interested about on a quadratic function, of course, are the vertex, which is going to be the maximum or the minimum point, depending on whether it's opening upwards or downwards. And we're also going to be interested, as we are with any function, with the zeros. And the zeros, hopefully by now, you equate that with the x-intercepts. And if we have these two things, we just about have what we want as far as graphing a function. Now there can be variations, of course. I mean, I could have a parabola. If I just do a quick little picture here, I could have a parabola that looks like this. And in that case, there are no x-intercepts. So we're going to want a little bit more information. Also, I guess I would add to this list that we would also be interested, of course, in the y-intercept. And there will always be a y-intercept for a quadratic function. And also, just generalizing here, let's just say this, that when we're dealing with these functions, we're going to be interested in two things. If you look at the middle of the page, we're going to be interested in going from the equation to the graph, and that might just be information about the graph. Maybe I don't want to actually graph it, but I want to know what the vertex is. And then we want to be able to go from the graph to the equation. And again, maybe I don't have the graph, maybe I just have some information about the graph, and from that information I want to be able to find the equation. So we're looking at a few quadratic functions here on this page, and the key thing about what makes a quadratic function from an algebraic standpoint is that it's a polynomial with the highest degree x squared. So there we have a standard form of a quadratic where we have ax squared plus bx plus c. Here we're not quite in that standard form, but we can see that if we expanded it, we would be able to manipulate that into that standard form. Here we've got a standard form, but it doesn't have a bx and it doesn't have a c, and that's okay, of course. And then finally here, this last one on the bottom is in standard form. So here are three. Let's just look at two of them and see about getting a graph or getting information about the graph from these functions. So here's the first one, and whenever we are doing any sort of graphing, I would recommend that we set up a function table. And I would also recommend that we always say what happens when x is 0 and what happens when y is 0. So in this case, when x is 0, we get 32, or 16, 32, 35 it looks like. All right, so that's your y-intercept. And depending on the convenience, we may or may not graph that actually. And then when y is 0, so I've got y is equal to 0, what happens? I've got 2 times x plus 4. Okay, so we end up here, and we could simplify this a little bit more. You should see here that I got a polynomial equal to 0. If I could, I would like to factor it. Obviously can't factor it, so I use the quadratic formula, since this is a quadratic. And here I end up with an imaginary value from this radical negative 24, meaning there are no x-intercepts. So going into the table, I'm just going to put a little dash there, and that's going to tell me that there are no x-intercepts. When y is 0, this is undefined. Okay, so I've got a y-intercept, I've got no x-intercepts. Let's just go back to the previous page for a moment. And what is it that we wanted? Look on the right-hand side of the page. We wanted the y-intercept, we wanted the vertex, and we wanted the zeros. Well, we've got the y-intercept and the zeros, and there are no zeros, so we're going to look for the vertex now. So let's go back. Okay, we're going to find the vertex by doing a transformation. So let's take this guy, and we're just going to transform this transformation of f of x equals x squared. That's going to shift us and shift us here. Now, the way these transformations work is the plus 4 is going to be a shift to the left, and the plus 3 is going to be a shift up. And then we also have to take into account the 2, which is the stretch. So that'll just take a moment to take that into account. If I take x squared here, and let's give ourselves a scale of 2, say, and then that would give me this point here, 1, 1, 2, 4, and then I've got the parabola shape there. Actually, I want that to be dashed, right? Because that's not what I'm ending up with. So I'm going to dash that. And then on the other side, it's going to be symmetric. And we'll have that. Now this is getting stretched. So looking back up to the upper left, this 2 is stretching it out, right? So let's just find one point that would help us do that. So instead of having point right here, look at the graph, instead of having point 1, 1, I'm going to have point 1, and then this 2 back up to the upper left. This 2 is going to multiply the y values by 2, okay? So instead of having point 1, 1, I'm going to have point 1, 2, and instead of having point 2, 4, I'm going to have point 2, 8, like that. So can you see that stretch? Like that. All right, and that's a vertical stretch. And then then I can go ahead and do the shift. And the shift is going to produce a graph. What did I say? 4 to the left. So I'm moving. So let's take the vertex here. If you look at the graph, take the vertex here, and we'll move that 4 to the left, and then we're going to move it 3 up. So I've got there, if you look at point -4, 3. All right, and then that was stretched up like this. And I'm not going to worry too much about the details. If I needed to, I could find a couple of additional points here, say here, and find out precisely where those points are at. Okay? And yeah, there are no details necessarily for exactly how many points we need or what points we're going to use. But just enough to give the general shape of the graph of the function. And we definitely would want to know, let's go back to that for a moment. We definitely would want to know that look, we know that this vertex is at -4 and +3. We know where the vertex is at. Now for this one, let's start off with that. Let's, well, actually, let's not start off with that. Let's do, like I said, to start off the other function, we want to go with xy table. So I have x, g of x, and then when x is 0, y is -7. When y is 0, we would want to be setting this equal to 0 and solving for x, and it looks like we're going to have to use the quadratic formula again. Okay, and once again, we've got ourselves no x-intercept, because I've got 9 minus 14. So we'll note that appropriately in the table. So no x-intercept, and then we'll go on to the vertex. Now on this part here, I'm asking you to remember that the y-coordinate of the vertex, I should say the x-coordinate of the vertex is -b over 2a. So I took the b, the 3, and I did the opposite of that, and then I took the a, I multiplied that by 2. So there's -b over 2a, and that comes out in this case to 3. And then the y-coordinate of the vertex is always simply this. If you look at the down to the right there, it's f of the x-coordinate of the vertex. So it just means once you find the x-coordinate of the vertex, plug it back in, plug it into the expression to find the y-coordinate. So there we have the y-coordinate of our vertex after plugging it in and simplifying. And we can put that into our table. We can say we've got x is 3 if you look over at the function table, and then y is -5/2. I can put a v there for vertex. I'm not going to go ahead and go into the details of graphing this function. And remember, I said we don't always need to graph it. Sometimes we're looking for just looking for some information about the graph and not going all the way to actually graphing it. What I do want to do is I just want to look at one thing with this function, and let me grab it here and take it. See, it is possible that you have learned or that you will be required in some class to convert this to this form. But what we've done, if we have memorized that the x-coordinate of the vertex is equal to -b/2a, we have essentially done this. And that's would be difficult to explain, but essentially what I'm doing is what I'm saying is that if you were to take y equals ax squared plus bx plus c, and if you were to complete the square, you would see in the process of completing the square that this is the x-coordinate of the vertex for any quadratic that is in this form. And that would be an exercise for another video or another lesson. So that's all I've got for quadratic functions at this point. I hope you can find equations and find vertexes and do your graphs, and good luck.